At the end of the lesson, you should be able to identify the standard and general form of the equation of a circle, write the equation of a circle given the center and the radius, and transform general form of equation of a circle to standard form, and vice versa. Let us begin with a review. Let us make x squared plus 4x plus blank a perfect square trinomial, and then afterwards express it as a square of a binomial. So let us illustrate first that a perfect square trinomial is actually obtained from the square of a binomial. Given this binomial, quantity x plus y squared, how do we transform this into a perfect square trinomial? So we have to square the first term first, which is x squared, and then twice the product of the first and the second term, and that is 2xy. And then for the last term, we need to square the second term, or the square of y is y squared. Now, how can we obtain if the last term is missing? So we will be using this technique. So firstly, you need to get the square root of the first term, and that is x. And then you twice the result, or 2 times x, and that will be used as the divisor for the middle term, and that is 2x. So 2xy divided by 2x is y, and then you square y, and that is y squared. Now let us deal with the first example. We have x squared plus 4x plus blank. So for the solution, we need to get the square root of the first term, and that is x, and then multiply it by 2, which is 2x, and then we divide 4x divided by 2x is 2, and then we square 2, or we square the result, and that is 4. And then from here, we transform it to the square of binomial form, and that is, we simply get the square root of the first and the square root of the last term, and that is the quantity of x plus 2 raised to the second power. Let us have the second example. We have w squared plus 10w plus blank. So again, for the solution, we need to get the square root of the first term, which is w, and then 2 times w, and that is 2w, and we divide 10w by 2w, and the result is 5, and then we square 5, and that is 25. Now for the square of binomial form, we get the square root of w squared, which is w, the square root of 25, which is 5. So the answer is quantity of w plus 5 raised to the second power. Let's deal with the third example. We have x squared minus 3x plus blank. So for the solution, we get the square root of the first term, which is x, and then multiply x by 2, and that is 2x. And then we divide negative 3x over 2x is negative 3 over 2. And then we square negative 3 over 2, or multiply it by itself, we have 9 over 4. Now for the square of binomial form, we get the square root of the first and the square root of the last term. So we have here the quantity of x minus 3 over 2 squared. So we have a negative sign since the middlemost sign is negative. Now let's deal with the fourth example. S squared plus 1/3 s plus blank. So for the solution, we get the square root of the first term, which is s, and then we multiply s by 2, and that is 2s, and that will be the divisor for the middle term. We have 1/3 s divided by 2s. So whenever we divide by 2, it means that we are multiplying by 1/2. So 1/3 times 1/2 is 1 over 6. And then we're going to square the result, 1 over 6, and that is 1 over 36. Now for the square of binomial form, we have the quantity of s plus 1 over 6 raised to the second power. Now let us determine the standard form of the equation of a circle. So the standard equation of a circle with a center at hk and a radius of r units is determined by the equation quantity x minus h squared plus quantity y minus k squared equals r squared. The values of h and k indicates that the circle is translated h units horizontally and k units vertically from the origin. On the other hand, if the center of the circle is at the origin or at 0, 0, it means that we are going to use the equation x squared plus y squared equals r squared. Let us have this example. Write the equation of a circle with a center at the origin and a radius of 4 units. So the center is at 0, 0 or the origin and the radius is 4. So we will be using x squared plus y squared equals r squared. So we simply substitute the value of the radius, which is 4, and then simplify. So the equation of the circle is x squared plus y squared equals 16. Let us have this example. Write the equation of a circle with a center at 2, negative 7 and a radius of 6 units. So the center is at 2, negative 7 and the radius is 6. So we will be using the equation quantity x minus h squared plus quantity y minus k squared equals r squared. Substituting to the formula the value of h, which is 2, and the value of k, which is negative 7. There we have quantity of x minus 2 squared plus quantity of y minus negative 7 squared equals 6 squared. Simplifying, we have quantity of x minus 2 squared plus, since we have here y minus negative 7, it will become positive. So plus quantity of y plus 7 squared equals 6 squared. Simplify, we have quantity of x minus 2 squared plus quantity of y plus 7 squared equals 36. Now let us deal with the general form of the equation of a circle, and that is x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are real numbers. Remember that the general form of the equation of a circle is actually obtained by expanding the standard form of the equation of a circle. For example, write the general equation of a circle with the center at 4, negative 1 and a radius of 7 units. Then determine the values of d, e, and f. So the solution, the center is at 4, negative 1 and the radius is 7. Writing this in standard form, we have quantity of x minus 4 squared plus quantity of y plus 1 squared equals 7 squared. Now from here, we need to express each square of binomial into a perfect square trinomial. So the perfect square trinomial form of this is quantity x squared minus 8x plus 16. And that is obtained by squaring the first, which is x times x, which is x squared, plus 2 times x times negative 4, which is negative 8x. And then to obtain the last term, we need to square the last term, or negative 4. So the square of negative 4 is 16. And then plus, we need to express this as perfect square trinomial again. So the perfect square trinomial form of this is y squared, which is y times y, plus 2 times y times 1, which is 2y. And then squaring the last term, which is 1 times 1, is 1, equals the square of 7, which is 49. And then from here, we're going to remove the grouping symbols. So we have here this one, and then for the next line, we need to add 16 and 1, or combine the constant term, and then arrange simultaneously in such a way that the first term is x squared, the second term is y squared, the third term is the term with x, the fourth term is the term with y, and the last term is the constant term. So that will be x squared plus y squared minus 8x plus 2y plus 17 equals 49. Since we want the right side to be 0, it means that we need to transfer 49 to the left. And that will become x squared plus y squared minus 8x plus 2y plus 17 minus 49 equals 0. So simplifying 17 minus 49, this is now the general form of the equation of the circle, which is x squared plus y squared minus 8x plus 2y minus 32 equals 0. We are ready now to identify the D, E, and F. So the D is the coefficient of x, which is negative 8, and E is the coefficient of y, which is 2, and F is the constant term, which is negative 32. Let us deal with this example. Transform the equation x squared plus y squared minus 6x minus 10y plus 18 equals 0 to standard form and give the coordinates of the center and the radius. So for the solution, firstly, we need to transfer the constant term to the right side of the equation, and then simultaneously, let us put x and y's together. So that will be x squared minus 6x plus y squared minus 10y equals negative 18. And then, put a grouping symbols on x and y's. So we have here quantity x squared minus 6x. And then from here, we're going to make this a perfect square trinomial. Remember the thing that we've done with the review? So we get the half or divide negative 6 by 2, which is negative 3, and then we square, which is 9. So it means that we need to add 9 to make this a perfect square trinomial. For this one, divide negative 10 by 2, which is negative 5, and then we square the result, which is 25. So it means that this one will become y squared minus 10y plus 25 equals, so whatever we have added to the left side of the equation, it will also be added to the right side. So it will become now negative 18 plus 9 plus 25. Now we have to convert this into a square of binomial form, and that is quantity x minus 3 squared. Square root of x squared is x, and the square root of 9 is 3. And then you just copy the middlemost sign. Plus what is the square of binomial form of this, which is quantity y minus 5 squared. That is obtained by getting the square root of y squared and the square root of 25, which is 5. And then copy the sign. Equals negative 18 plus 9 plus 25, which is 16. And then transforming this into a center radius form, we have the quantity x minus 3 squared plus the quantity of y minus 5 squared equals 4 squared. We can obviously determine now the the coordinates of the center, which is hk. So this is the h and the k, that will be the coordinates of the center, and the radius, which is r. So for the center, remember that if in this equation we have negative 3, we just get the additive inverse of negative 3, which is positive 3. And for the k, the negative inverse, the additive inverse of negative 5 is 5. So the center is at 3, 5. And the radius is, of course, 4 units. So graphically, it is here. So the center is at 3, 5, and the radius is 4 units. Let us deal with another example. Transform the equation 4x squared plus 4y squared plus 12x minus 4y minus 90 equals 0 to standard form and give the coordinates of the center and the radius. So for the solution, firstly, we need to transfer the constant to the right side of the equation. And then, since the value of a and b is greater than 1, it means that we need to divide the entire equation into 4. So this now will become x squared plus y squared plus 3x minus y equals 90 over 4. And then we have to group x and y or put x and y's together. So now we have quantity x squared plus 3x plus y squared minus y equals 90 over 40. And then we have to make this a perfect square trinomial. And that is by dividing this by 2 and then square. So 3 divided 2 is 3 halves. Raised to the second power is 9 over 4. So we need to add 9 over 4 here. Plus, since we have here negative 1, we divided by 2 is negative 1 half. Raised to the second power is 1/4. So it means that we have quantity y squared minus y plus 1/4 equals, so whatever we have added to the left side will also be added to the right side. That's why we have 90 over 4 plus 9 over 4 plus 1/4. And then we have to make this a square of binomial form. That's why we have quantity of x minus 3 halves raised to the second power plus the quantity of y minus 1 half raised to the second power equals, since we have a common denominator here or similar denominator, we can simply add 90 plus 9 plus 1, which is 100, and then divide it by 4, which is 25. Now, we have to transform this into center radius form. So now we have quantity x plus 3 halves raised to the second power plus the quantity of y minus 1 half raised to the second power equals 5 squared. So we can now determine the h and k, which are the coordinates of the center, and of course the radius. H and the k and the radius. So the center is at, since we need to get the additive inverse, so it means that the center is at negative 3 halves. Negative 1 half here will become positive 1 half when we write it as center. So the center is at negative 3 halves 1 half. And the radius is, of course, 5 units. So graphically, we can say that the center is at negative 3 halves 1 half. And the radius is 5 units. Try doing this on your own. Until our next session, thank you and enjoy learning.